Two black holes collide and space rings like a struck bell. Those rings are gravitational waves, real ripples traveling through spacetime itself. So space behaves like a medium, not a perfect emptiness. By medium, I mean something that stores and carries energy. Today we'll show how vacuum has stiffness, impedance, and waves. That hidden structure sets light speed and even whispers across galaxies. No old-school ether here, just fields and geometry doing real work. We'll see it in equations, in detectors, and in sky maps. By the end, empty space will feel alive with behavior. Immediate takeaway: space can transmit ripples and store energy like matter. So picture a medium, invisible yet measurable, shaping everything you see. Hold a flashlight in deep space, far from any dust. Light still has a fixed speed, set by space itself. A medium is anything that stores energy and carries disturbances. Knowing space behaves this way explains why C never changes. Electromagnetic fields fill vacuum, with built-in electric and magnetic responsiveness. Physicists call those responses permittivity and permeability of free space. Together they set the signal speed for light. See mathematically, C equals 1 over the square root of both. Permittivity is about 8.85 times 10 to the power of negative 12. In units, that is farads per meter for electric response. Permeability is about 1.26 times 10 to the power of negative 6. In units, that is henries per meter for magnetic response. Space also has a characteristic impedance, around 377 ohms. That number tells antennas how to launch power efficiently into vacuum. Example in real terms, a radio dish tunes to that background. Match poorly and energy reflects back instead of radiating away. These are not decorations, these constants are properties of space. Engineers design satellites around them because physics demands it. Combine them and C falls out as light's natural sprint. So the picture is, space sets the rules that light obeys. Now listen to spacetime itself, humming after a distant collision. A gravitational wave is a traveling ripple in the geometry. You care because it proves space can carry energy and information. The fabric stretches and squeezes at right angles, passing through everything. It moves at light speed because the equations demand that speed. The strength is tiny, measured as strain, a fractional length change. LIGO measures strain around 10 to the power of negative 21. Its 4-kilometer arms change by less than a proton's width. In 2015, two black holes merged, and Earth briefly trembled. About 3 suns worth of energy left as waves in seconds. The detectors saw the chirp sweep from 30 to 200 hertz. That chirp shape matched Einstein's prediction for orbit and crash. This is not sound, yet the medium analogy is precise. Stiffness sets wave speed in solids. Gravity's coupling plays that role. Weak coupling means tiny strain, yet waves travel cleanly across billions. Bottom line, space transmits transverse ripples, even when nothing else is there. 6 billion light-years away, a radio pulse leaves a galaxy. The path is not empty. Thin plasma threads fill the void. Here, the medium is ionized gas spread across cosmic filaments. You should care because this medium delays signals by frequency. Electrons jiggle and tug at passing waves, especially at low frequency. The group velocity drops a bit, giving a measurable arrival spread. Lower tones arrive later, while higher tones cut through faster. Astronomers read that spread like a mileage tag for distance. Fast radio bursts show dispersion measures of several hundred, sometimes more. A burst with DM around 500 arrives staggered by milliseconds. Across a 1 GHz band, the earliest part can lead by seconds. That timing pins down how much plasma the wave crossed. With enough events, we map missing baryons between galaxies. The medium analogy stops short of drag photons still fly at sea, but plasma changes effective index, and time stamps the journey. Example in real terms, FRB catalogs now trace matter between clusters. Net result, space behaves like a tenuous, readable medium on large scales. Zoom down between 2 ultra-flat metal plates, separated by a hair. The vacuum here is not nothing, it seethes with field fluctuations. That phrase means quantum fields never fully sit still, even at 0. You should care because these jitters push, pulling plates together measurably. The boundaries exclude many wavelengths, leaving slightly more pressure outside. Different modes fit between the plates, compared with outside modes. That imbalance creates a force called the Casimir attraction. The closer the plates, the stronger the push from vacuum energy. At 100 nanometers, the pressure reaches around 1 pascal. That is about the weight of a sheet of paper per square. Laboratories have measured this with torsion balances and micro-cantilevers. Changing geometry changes force, exactly like a medium with modes. This is not free energy. Accounting stays honest and conservative, but it shows vacuum stores energy, shaped by boundary conditions. Example, in real terms, nano devices must consider these tiny forces. Bottom line, empty space acts like a medium with quantized vibrations. Stand in a quiet desert night and power a small antenna. Invisible energy fans out as expanding shells, carrying information away. The surrounding space sets how easily that power leaves the metal. That property is the vacuum's impedance, about 377 ohms. You care because matching that number makes transmitters vastly more efficient. Currents in the antenna launch electric and magnetic fields together. The ratio between fields fixes how much power moves per area. Mismatch the ratio, and fields cancel or bounce back instead. Designers shape antennas to resonate, then couple into space cleanly. Rule of thumb, match the load and you maximize radiated power. A half-wave dipole near resonance can radiate with striking efficiency. Move into water and everything changes because the medium changed. In vacuum, the rules stay stable from radio to visible. That constancy lets deep space probes communicate across billions of kilometers. The reason traces back to those same constants, epsilon 0 and mu 0. Bottom line, space behaves like a transmission medium with fixed impedance. Spin a massive sphere and nearby space twists ever so slightly. That twist is frame dragging, a swirl in the space-time geometry. You should care because rotating bodies literally drag inertial directions around. Gyroscopes reveal it by drifting, even in drag-free satellite housings. The effect near Earth is tiny, but real and measured. Gravity probe B saw a drift of about 37 milliarcseconds yearly. Lasers tracked its quartz spheres, polished nearly to atomic perfection. Around spinning black holes, the effect grows huge, shaping entire disks. Orbits precess, and space behaves like it has a gentle torsion. It is not viscosity. Nothing is rubbing, only geometry guiding motion. The medium analogy helps visualize how rotation imprints on nearby paths. Example, in real terms, spacecraft navigation models include Lense Thirring torques. The numbers match predictions, confirming another property of the background. Bottom line, moving mass currents twist the medium that everything moves through. Galaxies drift apart and light between them stretches like taffy. The medium here is the metric, the scale of space itself. You care because expansion shifts colors and sets the cosmic timeline. As distances grow, each photon's wavelength grows by the same factor. Energy spreads over longer waves, so the light looks redder at arrival. That redshift is not ordinary Doppler through air. Geometry did it. Hubble measured a rate near 70 kilometers per second per megaparsec. A galaxy 1 megaparsec away recedes near that speed from us. One at 10 megaparsecs recedes 10 times that by the rule. Look at redshift 1 and wavelengths have doubled since emission. The cosmic microwave background stretched from visible-like energies to microwaves. This behavior screams medium, not because of friction, but because of scaling. Space has a dial that changes sizes everywhere over time. Example, in real terms, standard candles confirm this stretching with clean curves. Net result, the medium's scale evolves and light records every click. So where does that leave our ringing bell from the start? It leaves us with a simple picture that keeps paying off. Space is not a stage that does nothing, it participates. It stores energy, sets impedances, and carries ripples without stuff. It bends, it twists near rotation, and it even grows. Each behavior has measurements behind it, not just pretty metaphors. LIGO hears waves, antennas match impedance, and FRBs time the plasma. Casimir plates feel pressure, and gyroscopes drift exactly as predicted. The deeper payoff is practical clarity, for thinking and for building. Treat space as a medium, and puzzles often simplify cleanly. If this changed how you picture emptiness, consider subscribing for more. Bottom line, the bell keeps ringing once you know how to listen.